Okay, so let's talk about the types of bonding here real quickly, just to remind ourselves. And again, I'm going to draw this periodic table, one each on the left and right side in the first row, 2 and 6 columns over here, and then repeat that, 2 and 6, and then 2 all the way down, and 6 all the way down, and then in the middle here we've got 10 columns. So I've got 2, 6, 10, and then I've got the 14 down here. And those numbers are going to be really important to us, believe it or not. And we're going to remind ourselves that starting right here in the periodic table, I have a zigzag line. Remember, that's actually the name of this, the zigzag line. And it separates the periodic table into left and right parts. And we remember that on the left side of the zigzag line we have metals, and on the right side of the zigzag line we have nonmetals. Okay, and as far as bonding goes, remember that bonds, chemical bonds, are either the transfer of electrons or the sharing of pairs of electrons. And we remember that electrons are going to flow from left to right. They're going to flow from metals to nonmetals. Okay, so that if I have a metal and a nonmetal that are going to bond, or they're going to interact, the metal is going to give up electrons, one or more electrons, to the nonmetal. So sodium, for example, would give up its one outer shell electron to chlorine. And we're going to call that an ionic bond, because when I give up an electron, the metal forms a positive charge and the nonmetal forms a negative charge. In other words, they form ions, and then it's the ions that get together to form the chemical bond. And we remember, as far as energy changes go, that the formation of this bond is going to be much more stable than these two elements apart. And so when I form this bond, I'm going to release lots and lots of energy. On the other hand, if I have a nonmetal and a nonmetal that are going to bond together, both of these atoms want to hold on to their electrons to the same degree. In ionic bonds, the metals don't want to hold on to their electrons nearly as much as the nonmetals do. And we've already said that that's because of the size of the atoms. The larger the atom, the farther away from the nucleus the electrons are, and so the less they need to be held. And so metals with electrons, their outer shell electrons farther away, don't want to hold on to those electrons as much as nonmetals do. But if I've got two nonmetals, both of the things want to hold on to their electrons to a similar degree, and they don't want to give them up. And so in order for them to become more stable, they're going to end up sharing a pair of electrons, or more than one pair of electrons, and that will help them become more stable. And again, when we form this bond, this chemical bond, the substance is now going to be more stable, and energy is going to be released when that happens. What we don't talk about a lot is that metals can actually bond with metals. Metals can actually bond with metals. And hold on here, I'm going to need to power up my computer. Okay, we're going to find out that atoms of metals can actually bond with atoms of the same metal or other metals, but it's not quite the same thing as an ionic or a covalent bond. It's going to be called a metallic bond, and we'll talk more about that when we actually get there. So for right now, what I want you to do then is go back to the presentation here, and we'll read through this again. So another major component is the understanding of the nature of chemical bonding and the energy changes associated with bonding. What is the nature of the energy change that makes it desirable or not desirable for a bond to occur? And we'll talk a lot about that. For ionic bonding, we focus on the energy changes associated with the formation of ions and their subsequent electrical attraction. Covalent bonding will focus not only on the energy changes associated with the sharing of one or more electron pairs, but we'll also talk about the bond geometry. And with metallic bonding, we'll talk about the fact that the bonding occurs through formation of something that we're going to call a sea of electrons. So what I want you to do now then is in your graphic organizer under reactions, we're going to put bonding in this spot here, and we're going to put ionic, covalent, metallic here, and then we're also going to talk about the energy changes. Okay, and then we go on to the next slide. The last piece of the puzzle for reactions is the understanding of factors that determine how quickly a reaction occurs. And this is going to be the topic of reaction kinetics. And okay, I just tried something that didn't work, so sorry about that. So let's go back to Paint here. Open a new thing here. And so we talk about particles reacting. So if I've got a particle of oxygen and another particle of oxygen and a particle of carbon, so I've got atoms of these things, and they need to combine to form carbon dioxide. Hopefully one of the things that makes sense is that in order for me to form carbon dioxide, these particles need to smack into each other. Okay, I'm not going to form any carbon dioxide if these particles don't actually smack into each other or collide with each other. So they're going to have to collide. And so what's going to determine how fast a chemical reaction occurs is how things that cause chemical reactions, or how things that cause collisions increase. And one of the things that hopefully it makes sense of is that if these particles are moving faster, it's more likely that they'll collide with each other. So one of the things that we'll find out that will influence how fast a chemical reaction goes is temperature. The greater the temperature, the more collisions I get, and the greater the rate of chemical reaction, the faster it goes. The other thing that should make sense is that if I have more particles, if I have a lot more particles, if I have a lot more carbon particles and a lot more oxygen particles, then that's also going to increase the rate of the chemical reaction. So the two main things that we'll talk about when we talk about how fast a chemical reaction occurs are temperature. Increasing the temperature increases the rate, and concentration of particles. The more particles I have, the faster the reaction is going to go. Okay, so let's go back to our presentation. And oops. Okay, I'm struggling here. What's that?
You never want to hear an oops.
No? Okay. So this is the topic of reaction kinetics. So go ahead and put the words rate kinetics in that last box there. Okay, and then finally, there are two concepts that apply broadly not only to chemical changes but also physical changes: the laws of thermodynamics and the concepts of equilibrium. I'm not going to go into those right now. I'm just going to ask you to put these on your graphic organizer, and those go right up here. Thermodynamics and equilibrium. They apply both to physical changes and chemical changes, and we'll talk about those near the end of the course as well. Okay, so you've completed, well, let's go back here. We've got this graphic organizer now, and the way to think about this and the way that it's going to help us is to recognize we have this core concept of matter that has properties and undergoes chemical changes, and these core properties and changes are going to allow us to classify substances. They're going to allow us to classify matter. So physical properties and chemical properties will allow us to divide matter into pure substances and mixtures. Okay, there's only two choices there: pure substances and mixtures. And then when I look at pure substances, I can say I only have two choices. I've either got substances of one type of atom, which are elements. I've got substances of more than one type of atom, which are compounds. And now when I think about the elements, what things am I going to pay attention to? I want to know about atomic structure, the periodic table, and atomic properties, and I want to also know about the nuclear structures. So those are the things we're going to want to know about the elements. When we talk about compounds, that's not so much talking about the nature of matter, but it's talking about how matter interacts with each other. And we have all of these things that we're going to talk about related to chemical reactions. When we talk about mixtures, we talk about two things. Either it looks like a mixture or it doesn't look like a mixture. If it looks like a mixture, I'm going to call those colloids and suspensions, and we're not going to talk about those very much. If we talk about homogeneous mixtures, we're talking about solutions, and we're going to add the idea of solubility for solutions. And then for all of mixtures, we're going to talk about how we separate those. And then for matter, again, if I look at just the physical side of things, we know that matter has physical states: solid, liquid, and gas. And we're going to talk about how we change from solids to liquids to gases and the gas laws. And then finally, we're going to apply the concepts of thermodynamics and equilibrium to everything near the end of the course. So this is going to be our outline for the whole course. So you've completed the Nearpod presentation for this lesson. Take a picture of the completed worksheet and any other required materials, meaning the graphic organizer, and submit them through Canvas. And then you can go up here to the menu, the Nearpod menu, and click Exit and leave the presentation. Okay, and so that's the end of this recording.